Have you ever stopped to think about how your watch, your phone, and the cloud are all constantly talking to each other? It's like this invisible, silent conversation happening all around us, all the time. But how does it really work? Well, today, we're going to pull back the curtain on the networks that connect our entire world. Let's get right into it. So, it all starts with you, right? You're walking down the street, music is streaming from your phone straight to your earbuds, and your watch buzzes with a new notification. It feels completely seamless, like magic. But what you're experiencing is actually the first and most intimate layer of our digital world. Our journey starts with a network you can literally carry around in your pocket. You can think of it as your very own personal tech bubble, a tiny digital universe that just moves right along with you. And this image, well, it shows that personal bubble perfectly. Your laptop, your phone, even that wireless mouse you use, they're all part of this tiny little network that just orbits around you, all connected by short-range tech like Bluetooth. The real key here is proximity. A personal area network, or PAN for short, is all about low power and connecting devices that are just a few feet apart. It's super simple, really efficient, and honestly, it's perfect for the way we live our lives on the go. Okay, so that's your personal gear sorted. But what happens when you want to connect everything in your house to the internet? I mean, your personal bubble just isn't going to cut it. So it's time to zoom out just a little bit to the next level. Now we're talking about the digital nervous system of your home or your office. This is the place where all your different devices come together and start talking to the outside world. This diagram shows us two completely distinct worlds. Over on one side, you have your private network. That's the local area network, or LAN, where all your devices are connected. And on the other side, that's the public internet. So what's the bridge that connects them? Yep, that little box we all know and love, your router. And here's what one looks like in the real world. This thing is basically the air traffic controller for your entire digital life. It takes that internet connection coming into your house and creates a private, secure network for all of your devices to share. It's the unsung hero for sure. So we've covered your personal bubble and your home network, but our data travels so much further than that. So now it's time for the really big zoom out. We're going from our local streets to the entire planet. I love this slide because it shows how each network is kind of nested inside the next one, like Russian dolls. Your little personal area network is a part of your home's local area network, and that LAN connects to a bigger metropolitan area network. And it just keeps going, all the way up to the globe-spanning wide area network. Let's just quickly break that down. A LAN, that's your home or office, easy. A MAN, that connects multiple LANs all across a city. Think of a big university campus or a citywide government network. And a WAN, well, that connects everything over huge distances. And you know what the biggest WAN of all is? The internet itself, connecting billions of us all over the world. Okay, so we're always talking about the cloud, right? Like it's some magical, floaty place up in the sky. But it's not. It's not magic. All that data, every website, every single video you stream, it has a physical home, somewhere here on planet Earth. So where is it? All right, let's go check out the physical heart of the internet, the absolutely massive infrastructure that makes our entire digital world possible. This is the cloud made real. These are data centers, huge, secure buildings that are just packed with thousands upon thousands of servers. So when you save a photo to the cloud, what you're really doing is sending it to a hard drive sitting in a rack in a place that looks just like this. So yeah, a data center is way more than just a warehouse full of computers. It's a high-tech fortress. We're talking backup power systems, massive cooling units to keep everything from melting, and some seriously intense physical security. These places are literally the engines of the internet. So how on earth do you manage a network with thousands of servers? I mean, you can't just plug them all in randomly, right? No way. Engineers use this really clever layered approach called a hierarchical network design. The easiest way to think about it is like a pyramid. Okay, so at the very bottom of the pyramid, you've got the access layer. This is where your devices actually connect. Think of it like your local post office. Then the distribution layer is like a big regional sorting facility, gathering up all that mail. And right at the top, you have the core layer. This is the super fast backbone that zips your data across the country, kind of like a fleet of cargo jets. So we've seen the huge architecture.
Now, for our final step, let's zoom all the way back in and look at the fundamental nuts and bolts, the actual physical hardware that makes every single one of these connections happen.
Just take a look at the evolution of wired network speeds. It's pretty wild. We started out with early Ethernet at 10 megabits per second, which, let's be honest, is painfully slow today. Now we're at over 10 gigabits per second. To give you some perspective, 10 gigabits is fast enough to download a full HD movie in less than 4 seconds. That's a 1,000-fold increase in speed. Insane! And all that data has to travel over physical cables. The two main types you'll hear about are copper and fiber optic. Copper uses electricity, and it's great for your home's local area network. But for the super high-speed, long-distance connections that make up the internet's backbone, absolutely nothing beats fiber optics. They send data as pulses of light, which means they're totally immune to electrical interference. So I think the main takeaway here is that our wireless digital world is actually built on a very real, very physical foundation. It's this incredible, complex, global machine with all its parts working together just to bring you that next cat video or that message from a friend. We've already seen speeds increase 1,000 times over, and the technology just never stops getting better. So as we wrap this up, I'll just leave you with this question to chew on. What new possibilities, what amazing new worlds will we unlock when these connections become even faster than they are today? Thanks for joining me.